All right, we have our angle. I'll repeat a little bit since I just started taping. In standard position, XY is on the terminal side. We said that R is the distance from the origin to the point. And if we think back about unit circle values, the sine always corresponded with Y. Okay, cosine always corresponded with X, and tangent is going to be Y over X. Ty, when we look at reference angles in a few minutes, you'll see why it's Y and X. So if we know the sine, the cosine, and the tangent, then it's easy to find the cosecant, the secant, the cotangent, because these are reciprocals. So cosecant is R over Y, the secant is R over X, and the cotangent is X over Y. Now remember, I told you at the start of this unit, nothing that we're learning is that difficult, but we're looking at it in a lot of different ways, so you can't afford to get behind. Okay, so we have the point -3, 4 on the terminal side of theta. And I have drawn that for us. So if we want to drop a line that's perpendicular to the x-axis, we know that from here to here is -3, and this point is 4. And so what is R? 5. R is 5. And if you don't know that right offhand, you could always find that by taking the square root of -3 squared plus 4 squared. However, those are numbers that come into play a whole lot, and so that's 5. So what's the sine of theta in this angle? 4/5, because it's y over r. What's the cosine? -3/5. And the tangent? -4/3. So all you have to do in a case like this is figure out what r is. And r is always the square root of x squared plus y squared. And then if you know those first 3 basic trig functions, the sine is y over r, cosine x over r, and tangent y over x, then you can find all 6 of them. So not a whole lot different than from anything that we've done before. Same ideas that we're incorporating here. Now let's look at this next problem I have. It says, given that the tangent of theta, I almost ran out of ink, I had to change pens. The tangent of theta is -5/4 and the cosine is positive. I want to figure out what's the sine and what's the secant. So the reason that it gives you the cosine in addition to the tangent is because it gives us a clue as to which quadrant we're in. And I think we had talked about this before, but, no, I don't want that. I'm going to move that to the side for a second. When we think about the trig functions, I told you that they're all positive in the first quadrant. The sine and its reciprocal are positive in the second quadrant. The tangent and its reciprocal are positive in the third quadrant. And the oh, okay, never mind. That was my stepdad's in the hospital. My sister was sending me a text. And the cosine and its reciprocal are positive in the fourth quadrant. A simple trig chart. All in the first quadrant, sine and reciprocal second quadrant, positive. Tangent, reciprocal third quadrant, cosine and its reciprocal in the fourth quadrant. So in this problem that we just looked at, if The tangent's negative and the cosine's positive. What quadrant does that put us into?
4.
Good, quadrant 4. Okay, I'm going to move this out of the way. Move this back in. So we know that we are in quadrant 4. So that helps us because that tells us immediately what about the sign and the sign. Is it positive or negative? Okay, we know it's going to be negative. So I'm just going to go ahead and put a negative right there. And we know that the tangent, which is y over x, is 5/4. So if I know that, can I find out what r is? Okay, we know that it's negative 5/4, so that means the y is the part that's negative. But we've already taken account because we know that sine is negative in the 4th quadrant. So what is r going to be? Well, it's the square root of 25 plus 16. So we just have to leave it there. So what's the sign going to be? Negative 5 over the square root of 41, which we really don't want to leave it like that. And what is the secant? How do we find the secant? Reciprocal of the cosine. Is it going to be negative or positive? Positive. Okay, so what's the secant? Good. Easy enough.
So when you were trying to figure out what the quadrant is, what were you looking at again?
Okay, looking at the quadrant, tangent's negative, so that means we're either in quadrant 2 or quadrant 4. But the cosine's positive, so that narrows it down to quadrant 4.
Okay.
So that's the reason that we did that. Okay, let's go. All right, given that the sine of theta is 4/5. Okay, so the cosecant here is 5/4. That's easy. What quadrant are we in? 2. Quadrant 2. So what's the cosine? What'd you say? Negative 3/5. I wasn't sure if I heard the negative.
How do you know that though?
You know that the tangent is only going to be positive in either quadrant 2 or
Tangent's negative.
Quadrant 1 or, negative.
I know
Then
how
one
to
or
get
three.
quadrant 2.
So but then in your given sign, it's not negative, so you know it's not the 4th quadrant.
Yeah, but how'd you
What?
get
How'd you get 3/5?
Because when
Well,
you,
it's a 3, 4, 5 triangle.
yeah, this is 5,
Yeah,
4,
the
3.
Pythagorean,
Okay.
Like that's a special
With the
triangle.
side.
Special triangle.
There are 2 sides that are 3 and 4. The hypotenuse is going to be 5.
You know that r is 5. So 5 is equal to the square root of 4 squared plus x squared. If you don't know that it's a 3, 4, 5 triangle, you can always use the Pythagorean theorem. So 25 is 16 plus x squared. 9 is x squared. X is 3. Okay, any other questions on this one?
5 equals 6.
Pardon?
So you knew it was a special triangle because
The 3, 4, 5 triangle, 3, 4, 5 right triangle shows that a whole lot. But we know that r is 5 because we're given the sign. You know this is y over r. So r equals the square root of x squared plus y squared. So you can, if you don't know the special triangle, and some of them won't be those special triangles. So you just go ahead and fill into that equation and you can solve for the unknown. Okay, let's look at quadrantal angles. Quadrantal angles, we go back and we consider unit circle values. And real often, even, when I'm working on a calculus or a paper like this, or working on angles, I'll draw these quadrantal angles. I'll draw these points. Because we know here, hopefully you know that this corresponds to either 0 in radians or 0 in degrees. This is pi over 2. This is pi. And this is 3 pi over 2. And so if we want to use these quadrantal angles, find the trig functions for these quadrantal angles, you can this is a real quick reference. And we can use what we learned about the unit circle. If we wanted to find the cosine of 0, well, the cosine, does that go with x or y? Cosine is x. So the cosine of 0 is 1. What's the tangent of 0? Tangent is y over x. What is it? Undefined or 0? Okay, what about pi over 2? What's the cosine of pi over 2?
Square root of 2 over 2.
0.
Cosine of pi over 2 is 0. So what is the tangent of pi over 2? That one's undefined. What is the cosine of pi? -1. The tangent?
0.
The cosine of 3 pi over 2.
0.
And the tangent? Undefined. And you could find any of the trig functions of these are called quadrantal angles because they lie on the quadrant. They lie on the axis. So if you're talking about a quadrantal angle, they either lies on the x-axis or the y-axis. And that would be your 0, pi over 2, pi, 3 pi over 2, or 0, 90, 180, 270. So those are your quadrantal angles. And if you'll use those unit circle points, it's a real easy reference because you can always just jot that down on your paper, and it's a real easy reference. Saves having to memorize some stuff sometimes until you get real familiar with them. A reference angle is an acute angle. And it's the angle that is the acute angle that's formed from the terminal side of the angle and the x-axis. So I have 3 different pictures here. In the first picture here, here's my theta. But the acute angle that's formed between the terminal side of my theta and the x-axis is right here. That's my reference angle. A reference angle is always acute. So in quadrant 1, the reference angle and the angle are the same thing. In quadrant 1, the reference angle and the angle are the same. But in quadrant 2, the reference angle is the acute angle formed by the terminal side of your angle and the x-axis. So to find your reference angle, you subtract theta from either pi or 180. So if we're in degrees, we subtract theta from 180 degrees to get our reference angle. If we're in radians, we subtract theta from pi to get our reference angle. In quadrant 2, notice here, quadrant 3, theta ends in quadrant 3. Theta goes all the way, it's in standard position. This is standard position angle, that's theta. The reference angle is formed between the terminal side of theta, right here, and the x-axis. So this acute angle is my reference angle. And so to find the reference angle here, we take theta minus 180 degrees, or theta minus pi if we're in radian measure. All right, and then finally in the fourth quadrant, here's theta, here's the reference angle, the acute angle. Bless you. So to find, and the reason we do this is because a lot of times you'll be dealing with larger angles, but you know what the reference angle is. Okay, so in here, here's our reference angle. To find that one, we would take 360 minus theta, or 2 pi minus theta. Okay, for time's sake, if we have time after you finish your quiz, we'll come back and work a couple of these reference angles. There's some examples in your book. If we don't get time, I'll try to work these reference angle problems. We're going to go ahead and take our quiz. Your assignment is on page 316, and that is 10 to 32 even.
A question, will they see it, right there you have the numbers on there, so how would you know which one to use?
Like here,
Yeah.
what quadrant are you in? 300 degrees is in what quadrant?
Third, or the fourth?
Fourth quadrant. Okay, so that one real quick, we'll look at it. 300 is in the fourth quadrant, so we use this. So it would be 360
Okay.
minus 300 is 30 degrees is your reference angle.
Oh, okay, that makes sense.
Okay, this is radians. We know that pi is about 3.14. So what quadrant do you think this is going to be in?
Do you mean?
Do you mean 60 degrees on that?
Yeah,
one?
she does.
Yes, I do. 60 degrees, sorry. I'm in a hurry and I start writing things wrong.
2.3.
2.3 is in what quadrant?
Uh,
If pi is 3.14, it's in quadrant 2. So this would be pi minus 2.3.
Okay.
I want to go ahead and show you on this last angle. Notice it's a negative angle. And if you're not sure what quadrant that negative angle ends up in, the easiest way to do a negative angle is to change it to a coterminal positive angle. So we would add 360 to this angle, which means you're subtracting. So we have 5, 3 from 5 is 2, and 120, did I do that right? It's 10. 3 and 3 is 6, 225. Okay, so that's 200. That's coterminal with an angle that's 225 degrees. What quadrant is 225 degrees in? Quadrant 3. Okay, so if we're in quadrant 3, how do we find our reference angle? Theta minus 180. So this would be 225 minus 180, which means we have a 45-degree reference angle. Okay, so when you have a negative angle, the easiest way to do that is to change it to a positive coterminal angle. And then you can figure out which quadrant you're in.